All right, so the three different parts to 7, 8 were determining the area given 3 points, determining if those 3 points are collinear, and then Kramer's rule. So the area, you are finding the determinant, but you fill in that last column with what? Ones. So I would do negative. 3, 2, 2, negative 3, negative 4, and then fill in the ones on the end. Duplicate the column to the right. And then start to work your forward diagonals first. So negative 3 times negative 3 is 9 times 1, that's 9. 2 times 1 times negative 4 is negative 8. 1 times 2 times negative 4 is negative 8. So I get 1 minus 8, which is negative 7. And then go back the other way. 1 times negative 3 times negative 4 is positive 12. Negative 3 times 1 times negative 4, positive 12. 2 times 2 times 1, 4. So it's 24, that's 28. Negative 7 minus 28 is negative 35. And then the area is 1/2 of that. So it would be 1/2 of the determinant here. And I always make it positive. So that negative gets dropped off. And I would do 1/2 times 35, which is 17.5. So you can write it as 17.5, 17.5, but I do want you to actually go through the actual division part of it, or cutting it in half. Questions on that one? Yep.
It's like a fraction that's not over 2 and it's like more complicated to still.
It will always be over 2. Oh. Yeah, because that whatever you get out of a determinant is always a whole number. Yeah, and then you're always dividing by 2. So you just got to cut it in half. So it's either going to end a 0.5 or be a whole number. Okay, then collinear, you start the exact same way. So 0, negative 5, 2, 1, 4, 7, fill in your row of or column of ones. But for collinear, what are you looking for? How do you know if they're collinear? Good, if it's 0. So if I add these on, multiply this way first. So this is 0, negative 20, positive 14. And then back the other way. 4, 0, negative 10. Negative 6 minus a negative 6 becomes plus 6, which is 0. So these are collinear. So the question says determine, or the director said determine whether they are, not just the work, but the answer. You got to give them both parts. So the answer is that they are collinear, and the work is the backing of it. So look, some of you made that mistake on like the inverse for the quiz. Like you just did the work, but didn't answer the question. The question is, are they? Like it's either a yes or a no. It's an easy answer. And your work's supposed to back it, but the goal was to figure out if they are collinear, so you do have to give that answer.
Do you get any points when you just do this?
And you don't do any work? No.
What did you say? I was like, yeah, I might.
All right, so then Kramer's rule, and you'll get the same thing on the test, 2 parts, one with the x and the y, where it's only a 2 variable, and then one with all 3. So for these, I'm going to rewrite the matrix negative 7, 11, negative 1, 3, negative 9, 9. And then I have to find d sub x, d sub y. So d is the x's and the y's. Negative 7, 11, 3, negative 9. That's 63 minus 33, which is 30. And then d sub x. Take out the x's and add in the constants. So the first column becomes negative 1, 9, and then the y's stay. So I get 9 minus 99, which is negative 90, and that's d sub x. And then d sub y, take out the y's this time. So the x's stay, and the y's get replaced with the constants. Negative 63 minus a negative 3 becomes plus 3, negative 60. And then you want to put the d sub x over d, negative 90 over 30, which is negative 3, and y, negative 60 over d, which is negative 2. Good on that one. So I broke it down exactly almost like that. Like here's a little space to do d, here's a little space to do d sub x, here's a little space to do d sub y, and then here's your x and your y. so that if you make hopefully a silly mistake along the way, you're still earning partial credit for what you have right. Just be really careful. Fractions can happen, but probably not like 832 over 7, okay? But you could see fractions, like don't be scared by them. It's not like it's impossible to get fractions, especially as many systems I have to come up with as versions for your test. But they shouldn't really be like random and obscure. And the last one is your 3 by 3. So now I do a 3 by 3 determinant for all 4 of those. So D itself is the X's, the Y's, and the Z's. So 4, 2, 5, -1, 2, -2, and 1, 3, 6. Duplicate the first 2 columns. Work your way forward. So 4 times 2 is 8, times 6 is 48, -1 times 3, -3, minus, or times times 5, which is -15. 1 times 2 times -2, -4. So I'd get 33 minus 4, which is 29, and then go back the other way. So 10 minus 24 minus 12, 36, -26, and then 29 minus a -26 becomes plus 26, and this is 55. And then D sub X, I take out the X's and I add in the Y's. I'm sorry, take out the X's and put it in the constant. So -5, 10, 1, -1, 2, -2, 1, 3, 6, and then duplicate. And I go forward. So so 60. And then D sub Y, and I'm going to kind of like shortcut, right? D sub Y ended up being what, 110? One of them was 110 and one of them was
DZ
165, right?
Yeah.
DZ is 110 and DY is 165. Are they both positive?
Yeah.
Yeah. So then the X is D sub X, which is -55 over 55. The Y, 165 over 55. And the Z, 110 over 55. So this is -1. This is +3. And this is +2. Is it -110?
I got -110. Hold on, I didn't. I got positive.
And again, it's going to be broken down. This kind of question will be worth double what the other ones are. So you got to be careful because you're doing technically 4 parts to it. Okay, make sure you're careful. Make sure you show your work and watch your negatives. So the other part that I posted, the test review with problems from the book. So it's obviously 7, 8, which is all that stuff. 7.5 was adding, subtracting, and multiplying. Scalar and multiplying. So when can you not add or subtract?
When you don't have the same dimensions.
Have to be exactly the same. So have to have the same dimensions. And multiplying, what are you looking for?
That the outsides are the same.
Other way around. Inside same, outsides are the answer, right?
Yes.
So if I have a 2 by 3 and a 3 by 1, I can multiply them. The insides match. The outsides gives me my result. So these have to match, insides have to match, and the outside is the result. God bless you. Take your time on that stuff because people make silly mistakes, again, with the multiplication, trying to do it in your head. Okay, just be really careful and take your time with that stuff. That was 7.5, so that's on your quiz. 7.6 is on your quiz. That was your inverse stuff. So this is identifying if it's an inverse. So if I gave you A and B, you're either doing A times B and B times A to look for the 1, 0, 0, 1, or you can find the inverse and see if they match. I don't care which way you do it. Okay, but that one part of the question would be, is B the inverse to A? So the answer there is yes or no, and your work is your backing. And then the other one is finding the inverse. So this is where we did the little, so if I had like 1, 5, -7, 6, and I asked you for the inverse of this, you do 1 over the determinant times, and you'd flip the 6 and the 1 would switch, and the 5 and the 7 would change signs. So in this case, this would be 6 minus a -35 becomes plus 35. So this is 1 over 41, and then that would get distributed into each part of your adjusted matrix. So again, make sure you switch the A and the D, and you negate the B and the C. So the answer here would be 6 over 41.
Negate, you just like do the opposite.
Correct. So you don't move those other ones. 1 over 41. This would be the inverse to that matrix.
And then if it was a 3 by 3.
You won't do it. That's the one that took forever. So,
You,
yeah, I was literally worried you wouldn't finish. You're not doing the 3. Oh, that would be just to prove that they are inverses. But the one,
Finding inverse of it.
we're not finding of the 3 by 3. Yeah,
we're finding the 2 by 2 though.
you are finding the 2 by 2, which is that.
There's no finding the inverse.
There's no finding the 3 by 3.
How
I
would
wanted
you
you
do
to
that?
actually finish your test.
0, 0. The inverse of a 3 by 3?
We did it on the quiz.
I didn't take the quiz.
You should have taken
Yeah.
You do have to take that on the quiz.
Oh, you
Yep.
do?
The inverse is-
That's the
This one
1, 0,
here?
0, 0, 1, 0, 0, 0, 1.
Yep.
The super long distance.
That's the
Yep.
same thing as trying. So you have to do the.
You're basically doing Gosh Jordan on the left-hand
yeah,
side
yeah.
and what you're changing, but you have to change it to all 6 parts, not just
it. But he
3.
had to do it on the quiz.
He
not
still has to take the quiz,
Well,
yeah.
we already did it. Wait, so we're gonna have the Kramer's rule though with the 3 by 3?
Yeah, so that's what, Kramer's rule came in, the 3 by 3 went out.
Kramer's rule, I mean,
You get 1 with 2 variables and 1 with 3.
Nice.
I did.
Okay, so then 7, 6 was the inverse, and 7 was the determinant. So you're gonna get a determinant of a 2 by 2, but you won't get a 3 by 3 because you have to do it 4 times within the Kramer's rule. So, actually, I don't know if I did just a determinant of the 2 by 2 because I put it on the Kramer's rule. I can't even picture it anymore. But you obviously need to know how to do both because they both come back in 7, 8. Questions on expectations for your test? There's no calculator. I posted the review for today. You can check your odds already, and I'll go over the evens tomorrow. It is non-graded. I feel like at this point you have to figure out, do you need it or do you don't? And if you don't need it and you're confident, I hope you're right. And if you do feel like you need it, then spend the time doing it. If you do it tonight, I can answer questions on it tomorrow. If you save it for tomorrow night, you're on your own because we won't have time in class to go over it.
What's the determinant?
The determinant. That's the fish for a 2 by 2 and then 3 by 3, which is what we use in Kramer's rule. We just did the determinant more.
Wait, for 7, which is the one that you switched? You switched both?
I mean, the minors and codefactors.
Oh, we have no minus.
Yep, that's all. Yeah.
Minors.
So everything that was on your quiz, with the exception of the 3 by 3 inverse, plus what we did in the warm up.
Okay.
So exciting.
So the minors and the cofactors is in this section. That's in that section. Yes. Okay.
Nice.
Oh.